Hello everyone. Today we are going to discuss about data sharding. Data sharding is kind of partitioning technique where we uh, divide the data into the several smaller data so that we can access them easily and then manage them. So, uh, so data sharding is a type of partitioning that separates a large database into smaller, faster, more easily managed parts. And so if we talk about sharding, sharding is kind of, there's two kinds of sharding in general we talk about. Horizontal sharding is where you have the big table and then you cut the parts, you cut the table horizontally. So that is called horizontal sharding. And vertical sharding is when you have, you cut the table vertically. So uh, in short, actually, the schema is same in horizontal sharding, and in the vertical sharding, you take the subset of the schema. So all the columns come into the rows in the horizontal sharding. It means like if you have a table like this, and let's say for example we have the table with the customer ID, name, age, email, city, and if you want to cut this table, or in other words, if you want to shard this table, then we have to do it horizontally, or we can do it vertically also. So if we do it like this, if we take the certain portion of the data, let's say we cut it from here, and we take this part of the data, so that is one of the logical shard. So when you talk about shard, it's a logical representation of the shards, and we can put this logical shard into the physical machine or node or whatever it is. So then it becomes the physical shard. Uh, One of the additional point is that one physical shard or physical shard machine can have the multiple uh, logical shards. So in this example, I have taken this table and I am dividing this into the two shards, shard 1 and the shard 2. So as we can see that all the column names are coming here, whatever column names were there in the original table. So so coming back to the sharding, um, horizontal sharding, we do it horizontally. Vertical sharding, one example of vertical sharding comes into mind that if we are developing like Instagram kind of application, or some other photo sharing application, then we can have user data, we can have the images, videos, and other things. So we can decide to have the user data and all other things into one big server, or a set of servers, and photos and other things into the separate kind of servers. So logically, actually, we are doing the partition vertically. So for example, in this table, we can have customer ID, name, and age. So if we do it like cut like this, and I'm taking one example. So if you take this portion of the data, all the rows, it becomes your vertical shard. So depending upon the use, but normally when we talk about the sharding, it is horizontal sharding only. Um, so what are the advantages of sharding? So if you see high availability, your imagine if you don't divide the data, if you have a big data, terabytes or petabytes of data, if you don't do it, and imagine that only one server is handling all the requests. So now if you divide it, your database actually into the 10 shards, so all different shards can take the multiple requests. So now the work is divided among all of them. For example, this is your application server. Underneath, you could have several abstraction in between, and then ultimately, if you have a lot of shards or physical shards, so all the requests actually from your app, it would be coming to this, it would be coming to this, and it would be coming to this shards. So you can say that, and if one shard is not available, suppose, then you can have the replication also for this. So for every shard, you can have the some replication factor. Normally people put the three. So for example, any write or any read would come to this shard, and if it is write, it would write to this, and when both the writes are successful, then the success is returned back to the app. So what I'm saying that if you can say the high availability means if one of the uh, server is down, then you have the replica also here. And read write throughput, in the sense that now you can imagine that you have one read can route to this server, and at the same time other read can route to this server, and uh, write would be the different. And so you can imagine that now we are handling multiple read and write requests. So that is the advantage of database sharding, and of course with a high availability. So this was an example of horizontal shard. And yeah, now talk about the types of sharding architectures. So we have the key or hash based sharding. That how would you decide that which application requests from the end user would go to which of the database server, right? So you need to have some algorithmic logic or some function which decides that okay, you have to go to. So there are three techniques which can route your application request to to the appropriate sharding server. So key or hash based sharding, and other is the range based sharding, and the directory based sharding. So normally when we talk about key based sharding, so the situation is like this, that let's say we have a n number of servers, and we use some hash function, and uh, this key could be any user field and any user related data uh, based upon the appropriateness of that key. So we have to choose this key very carefully, because your data might not be equally distributed between the shards. So the key, this key or shard key is very important. In this hash key, so the hash function is applied, and the n is the number of servers, and there's a modulo operation. So this could be one of the technique, key based sharding. And based upon this, we decide, so request comes here, let's say we take the shard ID as a user ID. So user ID and then number of servers. Let's say we have the 4 servers initially. So the request would come to our API gateway or some server, and or load balancer, and then it would be deciding um, which shard would be used based upon this function. So for example, user ID is something, some username, and then we apply the hash function, we get this number, and if we take the modulo of that number, then based upon that return number, we would route our request. So this is key based sharding, and so this is key-based sharding, suitable for distributed data evenly to prevent hotspots. So we assume that if we choose this sharding key carefully, then all the data would be divided appropriately into the sharded server. But sometimes it does not happen. So we have the other techniques to solve that problem. We'll talk about that. And the other technique is other technique I talked about, the range based sharding. In the range based sharding, we can say that when the request comes, we can decide that this request would go to based upon the range of a particular key. For example, one range could be, if it is a username key, we can say username key if it is starting from A to D, it would go to this shard, and M to O would be this, and so on. So X to Z in the last one. So this is the range-based sharding, that we are saying that all the requests based upon a certain key, it would go to it would go to the uh, appropriate server. So that if we could see here, the problem with this approach is that data might not be evenly distributed, in the sense that suppose these usernames are very important singers. Let's say we have the Spotify or some other or Amazon Music kind of a website, and our song request is coming based upon the singer, and so we have the Bob Dylan or maybe other Britney Spears, and these kind of, and these are very celebrity kind of people. So if there's a more request for Bob Dylan, it would go only to this uh, 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 sharded server. So that is called the hotspot, data hotspot problem. Data hotspot, where one of the sharding server is bombarded with multiple requests. So if we don't distribute our data into this sharding server appropriately, then it happens. And so range-based sharding is nothing but we divide the data based upon the range of a particular field. And directory-based sharding is totally different. We have the lookup service, uh, and instead of doing our own logic, they have the table where they can see, okay, this data is in which shard. So they have the mapping of the DB1, DB2. So basically, your request comes, and the key value pair, through the key value pair you see where it should be routed to, instead of writing your own logic. And there's a different configuration in the directory based sharding. So you basically you go to the lookup service and ask. But from our system designing perspective, these two are very important, because sometimes we develop the distributed systems. We have different kind of data, and data always changes with the problem. When we talk about Uber, or when we talk about Facebook, Twitter, every time different services have different data needs. So based upon that, we divide the data and we choose our sharding techniques. So that's it for today. We talked about database sharding today, and what are the advantages of um, sharding, high availability, right throughput. And next time we'll be talking about disadvantages of hotspot problem when we do the sharding. If data is not distributed evenly, what problem comes up. And if we see here, the one of the key based sharding problem is uh, that if the server number changes here, if the server, let's say we have the 4 servers, and if you decide to change the to 5 servers, and that is the usual problem that happens all the time, that one server gone bad and maybe your service is hit. A lot of requests are coming now. They used to be 2 years back. So you have to scale the database. So you decide to add more servers. But if you add here more servers, let's say you decide to have the 10 servers now instead of 4. So this function changes. So wherever you are returning 0, it might be returning 1, or it might be based upon whatever is the last digit of the user ID. So let's say user ID is 1 2 3 4 7 8, right? So it would be going to the 8. Earlier, if you take this number, probably it would be going to the 0th, right? Because if you divide this number modulo take modulo, it would give you 0. So now you see that it would say that save your data into the different shard. So that becomes a problem because whatever data you were saving it earlier, now if you change the servers with the addition or deletion of servers, your all the data is distribution is changing. So that is the problem with the sharding and key-based sharding, and we do it. We solve this problem with another technique that is called the consistent hashing. So we'll be talking about that in the next video.